As you remember, the implementation process requires a buffer called ABCD buffer to give outputs of 128-bit hash value from the blocks of the original message. For this, we have to pass to the third step of padding. The third step requires an initialization for the buffer. A four-word buffer (ABCD buffer) is used to compute the message digits. Each of A, B, C, and D is a 32-bit register for this method. Once we know that in each A, B, C, and D is a 32-bit register, we have to know that these registers are initialized to the following values in a hexadecimal low-order bytes first. In word A, we have the following values. In word B, we have these values. In word C, we have these ones. And the last one for D, we have these ones. For the following, we have the fourth step, which is the process message in a 16-word blocks. In this step, there will be 4 rounds. Each round will have 16 iterations, making a total of 64 iterations with the 4 rounds. For every round, we will have a special processor function that is called as a function. These functions have special system operations to help the buffer in its performing. For the first round, we have this function. For the second round, we have this function. The third one for this, and the last one, this function. Once we know these special processor functions, we have the following question. How the values are changing in every round? Each round has a special formula, which is this one. This formula is in charge to process and transform the information in each iteration that is made in the program. As you can see, we have the value a equal to b times a plus the function of f with b, c, and d. In this part, we are saying that values b, c, and d are going to be the values of x, y, and z from the original formula or process function. So we are just substituting. But what is mi? This is in charge to break the 512-bit message into blocks. In this part, the MI is going to give us the specific number of blocks we want to implement in the method. There is a limit of 16 blocks of 32 bits for each one.